Hello, thank you for joining me. I am excited to have you with me today. We're going to talk about some very cool things, some very exciting stuff that's coming down the line now, and I am very happy to be announcing it. So I'm Leemon Baird with Hedera Hashgraph, and today I'm talking about the consensus service. We've talked about it before. We've had a lot of people excited about it, everybody wanting to use it, people use it on the test nets, and now it is available. And so everyone can use the Hedera Consensus Service. So we're going to talk about what it is and give you a chance to hear about someone building on top of it and hearing about the tools that make it easy for you to build on top of it and just kind of what you would want to use it for. And we'll even talk about their roadmap going forward, about what we're going to be doing. So the Hedera Consensus Service, this is a way that any application can have verifiable timestamps and it can have verifiable ordering of the transactions, and yet you have many of the advantages of a private network. You have the trust of a public network, you have advantages of a private network, all the privacy of a private network, all together in one thing. This is what HCS is about. It's about a consensus service from Hedera to allow you to do this. So where are we? Well, right now we have lots of applications and developers, lots of transactions going through us. You can just see a few of the people that are building, or have built on top of us, have deployed. We'll be talking a little bit about that. We have lots of transaction volume. We have the potential to be doing an enormous amount, and we are looking forward to watching it grow. It has been growing and is continuing to grow, so we're really looking forward to that. The system that we have, that we've talked about before, is like a neat ledger. It's a set of computers, those white circles. They talk to each other and get to consensus using the Hashgraph algorithm. We have services built on top of it, cryptocurrency, smart contracts, file service, and now, as of now, the consensus service. And the consensus service is something new. The consensus service is there because the consensus that we use internally for the network itself is Hashgraph. And Hashgraph is ABFT, asynchronous Byzantine fault tolerant, which means that you have these mathematical guarantees of fair ordering, fair timestamps, fair access, and that as long as more than 2/3 are honest, nobody can shut down the network, no one can force it to come to bad, different conclusions. We have very strong assumptions, even if the bad guys have great control over the internet. That's the A in ABFT, all that stuff. The engine is very fast and is very secure. And so, it's great that we've built services on top of this engine, but what we keep hearing from people is what we'd really like is to be able to access the engine directly. And that's what the consensus service is. So why would you want to do the consensus service? Well, you have other alternatives. You can use private networks, you can use public networks. If you use a private ledger, then everybody is inside the castle walls. You have the people that are using the network are inside. You have to approve of them. And then the computers that are running the network are inside. You have to approve of them. And the consensus happens all inside. And so everything is private. Why is that good? Well, you have privacy. If you want to keep secrets, or if you want to have personally identifiable information, or if you want to have things that need to be private, negotiations between a small number of people who don't want the whole world to be watching what they're doing, you need a private network. And you get privacy. You can get lower cost on storage too. Rather than put it on some public ledger, you could just store it in your private network because each of the members maybe has their own copy of the data. You don't have to have as many copies to trust it. There are a lot of ways that a private network is good. On the other hand, you still need most of them to be honest. And maybe you don't actually trust everybody in your private network. If you want true trust, you need a public network. With a public network, you have anybody can use it, and typically you end up with a wider range of computers that are making up the network itself. The consensus is still inside the network, but it's maybe a bigger network, and it's a network maybe run by people you trust, maybe because there's enough of them and you have proof of stake or proof of work or something to make sure that you trust them. In a public network, you have this greater degree of trust, and it's accessible to everybody. And that's great. And you can have transparency. If there are some things that you want to publish to the world and know that the world sees it and everyone in the world knows they're seeing the same things, like you're keeping track of real estate records, then you want public. What's interesting is to get the best of both worlds. And this is what an Appnet is. An Appnet is where you have your computers in your network, and it's just like a private network. You could set up your own computers, but the consensus engine is outside of your network. The consensus engine is Hedera. And so you get the full trust of Hedera, of the Hedera Council. You have the full trust of that in your network. And so the Appnet can have the privacy and the low-cost storage of a private network. But it can have the trust and the transparency when you want to be transparent of a public network. And you can have a mixture of some things you make private and some things you make transparent. And you get both at once at the same time. It's the best of both worlds. And that's what Hedera is doing. We are allowing you to have Appnets. Ooh, is it hard to build an Appnet? Is it as hard to build as your private network? No. In fact, if you have a private network, we're making it very, very easy that you just plug in the ability to use Hedera for the consensus engine, and you just keep using the same network. You have the same tools, you have the same software, you have the same people running the computers, but now you've become an Appnet, and it's very easy to do, and we're writing software to make it easy to do, plugins into Hyperledger and Ethereum and other things. So we want to make it as easy as we can for you to have an Appnet. And if you want to start from scratch, we make it easy to do that too. So this is the point of an Appnet. We're trying to harness the ability of getting the trust, inheriting the trust of Hedera and the high speed of Hedera, but have the privacy and the low cost of a private network, and then have the trust and the transparency of a public network. So that's where we are. So how does this work? Well, suppose that you wanted to set up a private network to do, say, a stable coin. What you might want to do, I said a private network. That's not so good, because for a stablecoin, you need great trust. So what if you wanted to do an Appnet? Use the consensus service to do a stablecoin. You set up some computers, computer 1, 2, and 3 over there. That's your network that you've set up. It can be you and your friends. It could be strangers. It doesn't have to be people you trust. It doesn't have to be people that the outside world trusts. But you set up a bunch of computers. And then you have them store the information. So for a stable coin, they keep track of how many coins each account is holding at the moment. Or they keep track of how there have been trades between people if you're doing transactions that are spending these coins. And this information is entirely held on those computers, not on Hedera. So if you want privacy, you can have privacy. You can have everything private there. Or if you want some things public and some things private, you have that choice. Anytime someone is transferring a coin, though, to get the trust, you pass it through Hedera. So Hedera puts them in order, and nobody can do front running easily and get them out of order. You just encrypt your messages, you send them to Hedera, and it isn't until they come back and are already in order that they are now in the appropriate order, and that they can be decrypted. And so you can avoid some of the front running problems that you have. You have, which is where people find out the information too early. You can take care of that. Also, you don't have to worry about a dishonest person manipulating the order to be in their benefit. So if this is like a little stock market, you don't have to worry about that. And you can have all of the trust of Hedera for the timestamps. So you can prove that you did something before noon, and you don't have to worry about some attacker manipulating that timestamp. Hedera does that, puts them all in order. It sends back all the messages that you sent in the order that it says is the consensus, and can send it with state proofs, which will be able to show you for sure that this is truly the order, and you can prove to another person this was truly the order, and prove that these are truly the trusted, fair timestamps. And we have the fair timestamps, we have the fair state proofs, the fair order, and the state proofs of it all, and we can send it back to the network. Your Appnet might have one computer that acts as a mirror node. Mirror nodes are ones that reflect what was on Hedera. What the results were from Hedera. They see all the transactions from Hedera. So you might have one node as a mirror node, the others aren't, and then you have the mirror node pass on the messages to the others. What if the mirror node is dishonest? Who cares? It passes on the state proofs, or it can give them state proofs, generate its own, and it guarantees that Hedera stands behind this order. And so if you trust Hedera, you can trust it even if you don't trust computer number 2, which is the mirror node distributing them. You don't have to trust it. They don't have to trust each other. And if you are mirror number 2, computer number 2, of course you trust it. You're trusting yourself, which is, of course, the beauty here, is that you don't have to trust anybody in the network except for your own computer. Trust one computer. You don't have to trust anybody in that Appnet. You just trust Hedera. Okay, so this is how the consensus service works. You get good privacy and good trust. Best of both worlds. And in addition, you have now stood up this thing that we call an Appnet, which could have just been some existing private network. And you just put in the plugin to swap out where the consensus is coming from. Just using a new consensus engine where the engine is Hedera. And so it inherits the trust of who Hedera has running the nodes. This is how an Appnet works. Now, that was one example of an Appnet. There's actually lots of things you can do. Almost anything you would want to do in arranging this network, you can do, and it'll work. And so you have huge flexibility. And we're writing libraries for you to make it easy to take advantage of all this flexibility, because we want you to be able to do anything you want with it. So what can you do? Well, as I said, you could do it this way. There's one mirror node. Everybody sends their encrypted messages to Hedera, and the mirror node gets back the answers and then passes it on to everybody. All the processing happens in the Appnet. Hedera never has to do the processing, doesn't have to decrypt any of the messages. Everything happens in the Appnet. That's what I just showed you. Another alternative is let everybody be a mirror node. Then everybody can send in their messages, and everybody gets back the messages. You don't even have to have the state proofs. And if there's ever a dispute, computer 1 and computer 2 are arguing about what the state really is, they can go to court, and they can show the court the state proofs and all of the messages, and the court will know the true ordering of the messages. It can figure out what the true state should have been, and they can prove it. And so nobody can get away with cheating, which kind of makes it not worth cheating, because you can't get away with it. You can always go to a court and get rid of it. So this is a really nice option. Let everybody be a mirror node. Then you're just really independent, and you never even talk to each other. Or don't have a mirror node at all. Use some external party that runs a business of being a mirror node business. And this is a good business to build on top of a mirror node. You know, the mirror node software is open source. Anybody can download it right now. Anybody can be a mirror node. Anyone can run mirror nodes. We have several companies that are already running mirror nodes and building really cool services on top of it. So you could go to a mirror node service. Everybody sends their encrypted messages to Hedera, and they all then come back to the mirror node. And then the mirror node streams it out to everybody that is subscribing to it. You can do a pub-sub model. You publish to all the people who subscribe to you. And it'll only send you the messages that you're interested in, like only the ones relevant to this Appnet, only the ones on one topic. They're divided up by topics, so an Appnet has a topic. So everybody is getting it from the mirror node. Or just computer 2 is getting it, and that computer gives it to the other ones. You could do it any way you want. You can spread it any way you want. You could gossip it if you wanted to. Or just everybody gets it directly from the mirror node. So this is how to use an external mirror node service, which makes your Appnet even simpler. And because you don't really have to have any trust in the Appnet, you could even use a cloud service. Just stand up a bunch of instances in the cloud. The Appnet can be very simple. The Appnet could be one computer. This is just really simple what you can do. Okay. Or another thing you can do is use your Appnet to provide a service to the world. This stablecoin could have just been for people in the Appnet, or it could be to a huge group of people who are all exactly KYC'd, which is sort of still permissioned, sort of private, or it could just be to anonymous users. You could open it up to the world and have any anonymous user be able to use it. However you decide you want to set it up, you can set it up. It can be public and private, or a mixture, or in between. But the user then, when they want to do some transaction with you, maybe to move one of your stable coins around or bid in your stock market or play your game, the user sends their message encrypted to the Hedera network. It sends it back to the network, maybe through one mirror, maybe through multiple, maybe through an external mirror. You can mix and match all these things. And then the network figures out how to update its state. And then every computer in this Appnet has the state. So the user can talk to any computer. The user could talk to computer number 3 and make queries and say, hey, what's my balance? Hey, did I win the game? Hey, what's the state of the game board now? Or what's the state of the stock market? Did I get my bid to go through? Did I find a buyer or not? The user can ask Carol, and Carol can give an answer. Maybe the user only trusts one member of this Appnet. They can ask the question to that member. Maybe they only trust a few members but don't trust them that much. They could ask several members and see if they all give the same answer. Maybe they don't trust anybody in the Appnet. then they could demand that the Appnet give them state proofs with a bunch of history of messages, and they could recalculate it and could actually verify that it was actually true. Maybe they don't want to do that effort themselves. They hire an outside auditor to do all that work of auditing the Appnet. In fact, the auditor can actually do that by talking to a commercial mirror node and never even talk to the Appnet people. They could do an independent audit without even talking to the Appnet people and could find out that they're telling the truth. There are lots of options for external users with an Appnet, and they all come down to one thing. You're inheriting the trust from Hedera, so you don't have to have the Appnet build the trust. That's the whole idea. I said you can make it even simpler. Maybe your Appnet is one computer, or even one instance in the cloud, and it acts as a mirror node, maybe even uses an external mirror node, or does it itself. It sends in encrypted messages, just records of what you're doing. Maybe you're an advertising company and you want to record all of the impressions as they happen because you want to eliminate fraud in the advertising industry, which is what AdsDax does. They built on top of us to do this very thing. And they're moving to the HCS. They've been working on this because they're very excited about doing this with HCS. And so they are sort of a one-node Appnet that sends the things to the Hedera. Hedera puts it in order, sends it back, and then when it comes back to them, they just log it all. They just keep a record of it all with the information from Hedera, which ends up proving that they did it when they said they did it. And they can also send it in real time to, you have publishers and advertisers, and they can find out what each other are doing in real time. You can do all of that in real time. Just sending the information to people that are interested. And I say here the messages come just to the computer that's running this Appnet, but then that one computer can send it to an auditor. Maybe an annual audit or a daily audit or whatever. Or give it to an auditor once an hour, and the auditor can see they're doing the right thing. Or give it to their advertisers and their publishers and make sure that they're doing the right thing. There are lots of ways that you can have an Appnet of basically just one computer, which then talks to others and proves that it did the right thing. And as I said, the mirror node could even be external, and the auditor could audit without even talking to the Appnet. They just get it directly from the mirror. And the mirror could be a mirror node chosen by the auditor from a whole ecosystem of mirror nodes, and the Appnet doesn't even know which mirror they're using. They could switch between mirrors. That further reduces fraud. There's just a lot of things you can do here that all comes down to the trust of Hedera. I said encryption. You can encrypt things with a key. You can even change the key frequently, very frequently. We'll talk about cryptographic ways of doing that. It's very exciting. But you can do ways that you can change the key continuously. It gives you something called perfect forward secrecy, and it just ensures that the data flowing through Hedera, if an attacker doesn't get your key within the next few minutes before you change it, then the attacker could never decrypt it. And you can ensure that no one in the world who has seen these encrypted transactions will ever be able to decrypt them, even if you lose the keys in the future. And so the bad guys get the keys, they still won't be able to use it because you change keys every few minutes. So they're out of luck. That's the idea. So the concepts we've talked about is the messages are what you send to Hedera. Hedera doesn't even know what they mean. Hedera, we just put them in order and we put timestamps on them, and we do it in a way that you can trust. Your privacy can be ensured by encrypting and even having perfect forward secrecy so that no one in the world could decrypt these after you've thrown away the key. And you can throw away the key every few seconds or every few minutes if you wanted to. I guess you could do it every few seconds. But generally you do it every few minutes or maybe once a day, but you'll periodically change your keys just to prevent that. We have different types of messages. I said you could encrypt it with these short-term keys. You could also just have a key that you use forever and encrypt it with a long-term key. Or you could even just send plain text. Why bother with encryption if you don't care about people seeing it? You don't have to get privacy. You still get low-cost advantages of having an Appnet. Do that. We talked about the mirror nodes. They're the ones that are spying on Hedera. They get everything that Hedera does. They even verify that Hedera is doing the consensus the right way. They are observing how the consensus happens. They watch the sausage being made. They are the ones that are seeing that everything is going on and that it's going on correctly. And they can give the information with proofs. And they say, don't take my word for it. Take Hedera's word for it. That's what the state proofs do. We have a running hash in these messages so that we give you a proof on one message and it proves that all the previous ones that you heard about are correct. No messages are left out. No messages are inserted. No messages are modified. Everything is guaranteed to be right when you get a state proof on just one message at the end. And those are the state proofs. And I talked about topics before. Each AppNet might have its own topic, or they could share topics, or you can have multiple topics in an AppNet. The idea is that whenever you submit a message to us, you say which topic it's for, and then you could subscribe to just one topic, or just a few topics that you're interested in. It's a way of building channels for these messages. So, the important thing here is, what can you use it for? Armada Chain is using it for supply chain management. Nickel is using it for bidding and markets and trading. AdsDax is using it for audit logs, like I was just talking about. And you can use it for all kinds of audit logs. We're finding a lot of interest in the space of audit logs. And then Sky people are doing games. I love it. And so these are people doing all sorts of really interesting things. And they're building on HCS. They've had early access to it, and now the world has access to it. And we have a white paper, and you can download that from the website and get more information about the HCS, and you can download code. And this is important to make it easy for you to take your existing tools, your existing private networks, the existing tools that you've written for them, and just reuse it all. We're building plugins, we're building additional tools for you, additional libraries. And to talk about some of that, I'd like to introduce you to Greg Scullard. He's a developer advocate at Hedera. He advocates for the developer community. He learns what you want and advocates for you within Hedera to make sure that we are doing what you need. Let's hear from him. Greg?
Thank you, Leemon. Now let's take a look at the HCS SDK Extension Components, which are an open source project which exists to provide a number of features to help developers create applications more quickly. In its most basic form, an application would likely interact with an end user, although the application could be purely automated. It will generate messages, which we call business messages, and send each of those messages to Hedera inside a consensus submit transaction on a given topic ID. The resulting transactions are ordered within the topic by the Hedera network and made available to applications via mirror node subscriptions. Each application within the Appnet is made aware of new transactions through those subscriptions and can process the message that was included in each of the transactions. The process repeats until the application is turned off. Now, building one of those applications with the available SDK is pretty simple. You create a new topic ID, you create transactions on that topic ID, you query a mirror node or subscribe in the first place, receive the results of the transactions and process them. But once you've done this, you might realize your application needs more capabilities. It may need to persist the transactions it has sent and the notifications it has received from mirror nodes. It may need to detect and handle malicious activity. It may need to handle messages that are larger than the Hedera transaction will allow. It may need to catch up with historical messages. It may be desirable to sign outgoing messages so provenance can be verified by the recipients. And finally, since Hedera is a public network, some encryption might be desirable, likely symmetric encryption so data is not visible to third parties. Better still, it may be desirable to rotate keys on a regular basis to further enhance the security or privacy of the messages. To help with all this, we've been busy writing a set of extension components to the Java SDK, which in time will provide all the features I've listed now, and probably more. The project is open source, it's available from our Hashgraph GitHub repository. You will also find two applications we've built using the extension components. A simple console-based message application where 3 apps communicate with each other, and a more complete demonstration showcasing a settlement process between multiple parties. We wanted to go beyond the get you started examples and show you more complete applications that you can inspect, tear down, improve, or use as a starting point to build your own. So what have we built already? Large message chunking is taken care of. If your application needs to send large messages, the extension will break it up and into smaller chunks and reconstitute it back from mirror node notifications. Plugins for persistence are also available, either in memory or in database. The persistence of the data enables you to build audit into your application and catch up with any missed notifications since the last time the app was running. Those two demonstrations are Dockerized so that you can spin up an example Appnet in no time. We're also working hard on improving those components We will enable you to sign messages via a plugin, every message or just those that you want. We will implement a symmetric message encryption plugin. This is different to signing in that the message is encrypted and can be decrypted with the appropriate key. Further, we will add key rotation to this plugin so that only a subset of messages are only ever encrypted with any given key. Finally, we will add malicious activity detection, ensuring messages are processed in the right sequence, checking hashes from one message to the next, etc., etc. Most of these will be implemented as plugins, so if a different signing scheme is ever desired, it should just be a case of creating a new plugin. Likewise for encryption and key rotation. Quick note to say that those components are not intended for production use at the moment, and that some of the components features may migrate to the SDK if we feel that the SDK is the right home for those features. Now let's look at the settlement demo. It's an application written in Java that uses the extension components. It runs a web server which serves a HTML page to a web client, and behind the scenes the application submits transactions to Hedera and subscribes to a mirror node. We have 8 instances of the application running as Docker containers, so each user you'll see in the demo is managed by an independent application instance. We'll see Alice issuing a credit note to Bob in exchange for a service from Bob, and we will do the opposite, Bob issuing a credit note to Alice at the same time. Both will then accept the credit note, thereby acknowledging they have received it. In both instances, a transaction containing a message is generated by an app instance, sent over to a Hedera node chosen at random, which is the blue arrow on the right-hand diagram. Once Hedera reaches consensus, the result of the transaction is available to a mirror node, the green arrow, and the mirror node notifies the apps subscribing to this topic, the purple arrows. In the full demo, we would then aggregate the various credits into a settlement and process that settlement through a third-party application user, another app user in the Appnet. We'll also look at some other areas of the demo, such as auditing, so you can see the messages that are being generated and received. So here I have the demo. I've opened a number of tabs in my browser, and if I look at this very first tab here, I can see my 8 users running in independent virtual machines, and they're all available on these different on these URLs on different ports. So we'll be looking at Alice and Bob, who are buyers and sellers, but you can see different user profiles here for Diana as a pay channel, Farouk as an arbiter and auditor, and Henry is another pay channel. Okay, so Alice here has selected Bob as a user, and she will be creating a new credit, and this credit will be for, so this is from Alice to Bob, and it's $120 for service ABC. So she's essentially saying to Bob, I will pay you $120 in exchange for this service. If I switch over to Bob and look at Bob's credits and debits, and he will create a new credit line with Alice. So this one is from Bob to Alice, and it's for $80, and this is for service DEF. And we can also see in the background here that Alice's proposal for credit is already visible. So let's take a quick look at audits. So we can look at some of the detailed messages that are going on. So this message here, or this audit line, is for a credit. It was proposed on topic ID 1196, and it will be Alice's credit to Bob. So we can see here an application message ID. This is a unique identifier that we generate with the extension components. There is a thread ID, which basically joins up a number of messages together from the application's point of view. And this is a credit. The payer is Alice, the recipient is Bob. This is an Alice to Bob conversation, and the value is $100 for service ABC. If we look further down, we can see the notification that we have received from Mirror Node, and this includes the consensus timestamp in seconds and nanos, the running hash, and basically that running hash gives us confidence that every message logically follows the previous. We have a sequence number so that we know in which order these messages, the different messages from Mirror Node, have been ordered by the Hedera network. And inside there, we have the message, which is our business process message. This is application specific. And this business process message is my Alice to Bob service ABC for $120. We can also see that it's part 1 of 1. So if this message had been chunked, we would have multiple parts here. And this is the topic ID on which it was sent. So let's go back to credits and debits. I can see I have some bold here, suggesting that there is an update. So we can see here, again, I'm Bob, and I can see a payer Alice Bob and a proposed credit, which I will accept. So this is for the first ABC service. So Bob will accept this and essentially notifies Alice that he's okay with that particular credit. And Alice will do the same to Bob. She will accept and confirm. So if I flick back to Bob, we can see Bob's credit now shows agreed, and the one he sent to Alice is still showing up as, well, it's just updated itself. It's now showing up as agreed. If I go back to Alice, we can see that both are agreed. The next logical step in the process, in the demo that we're not going to go through just now, is settling, and this is essentially Alice and Bob settling their credit differences, and in this instance Alice owes Bob $40. So let's take one last look at audit. We can see here that second credit line from Bob to Alice. We should see 2 messages, the original credit and the acknowledgement. So this is the original credit, Bob to Alice for $80 for service DEF. You can see the same thing that we saw earlier in the case of the Alice to Bob message. And this is Alice's acknowledgement of the credit. And we can see it's a credit acknowledgement here, application message, and the notification here from Miranode with the slightly less details, because in this case this is just an acknowledgement. So we're just acknowledging that particular thread and that particular service. And again, we have number of parts and the topic ID. And that concludes the demo, and I will now hand over to Rhys from AdsDax, who's been developing on the Hedera Consensus Service, and he'll tell you all about what he's been up to.
Thanks, Greg. Hi, everyone. I'm Rhys. I'm the lead developer from AdsDax, and I'm here today to talk about our implementation using the Hedera Consensus Service. So to give you a little background on AdsDax, we're a rich media mobile advertising company, and we have a 10-year track record in developing bespoke, data-driven rich media solutions for our advertising partners. To give you a little bit of background about AdsDax, we span both the demand side with our advertising partners and also the supply side with our publisher network. And one of the things that we're doing is, since early 2017, we've seen the problems that the advertising industry has, and our aim is to reinvent the advertising industry and solve those problems using DLT. So looking at the current problems with the advertising industry, advertisers have no direct relationship with consumers. So this is something that we aim to bridge the gap using DLT. There's a lack of transparent access on the data. So currently, everyone's data is in these black boxes, in these RTB programmatic buying systems, and no one really knows who's using it and what they're using it for. This data is taken for free from consumers who have no control over what data is shared. And then also, there is a massive amount of waste and fraud that goes on in the industry, with some estimate of almost 75% of the advertising spend being wasted and spent on middlemen and fraudulent traffic. To take you through the current process, some of this will be familiar to you if you saw our blog post that we launched recently. But essentially, on our advertising platform, we track payable events as they come in. We verify those events and make sure that they come from trusted, reliable sources. We pass those events to our pool of workers. So we use a message queue system called Beanstalk, where we have these pool of workers that pick up all of these events, they bundle them into transactions, and then they send them off to the Hedera network using the crypto service. Once we have sent those transactions, we create receipt jobs in a separate tube, so we have a separate pool of workers who then get all of the receipt and record information back and take that, process it together, and add it to our log files and into our database. To compare this with the Hedera Consensus Service, a lot of the initial process is still the same, so we still get all of the payable events from the user, verify that information, like I say, make sure it's from a reliable source and it's a true and accurate event. We utilize a separate queue for HCS processing. So currently we can use a hybrid system using both the crypto service and the consensus service as needed. But one of the main benefits for the Hedera Consensus Service is that it allows us to store a lot more granular information. So unlike the crypto service, using HCS, we can store the full event data as needed. We do this using a hybrid public and private information system. So our messages, they contain some public information that is transparent and viewable on the ledger. And also we use AES 256 encryption to include private information. Now the reason that this information is encrypted is it's potentially very sensitive information. So it may contain information on the user, or also sensitive information for the advertiser, such as the price that they've paid for any advertising. So benefits of the Hedera Consensus Service compared with the crypto service. Initially they may appear quite similar, as both the cost and the throughput of the crypto service versus the consensus service are very similar. However, the consensus service allows us a very flexible approach for how we set up our topics, so we can do this on an advertiser, campaign or advert basis, allowing us to meet the advertiser's needs. And also the large message size with the consensus service compared to the crypto service is very beneficial to us. So a crypto service memo is limited to 100 bytes, whereas a consensus service message is you can use up to 12 kilobytes. Also, one of the benefits of the consensus service is that we can use this hybrid public and private encrypted data so that we gain all of the benefits of ABFT. All of the information is stored transparently on the ledger. However, any of the sensitive information is stored in an encrypted format. Advertisers can use the decryption keys to go and check using any of the mirror nodes, check the data that is in the transaction is true and valid, but it's stored in an encrypted format. And then also, one of the benefits is that it allows us to separate the transfer of value associated with the crypto service from the pure tracking logic. This is potentially beneficial in certain regions of the world where the legislation around crypto is slightly less friendly. So to use an example of India, there are currently ongoing court cases around whether crypto and crypto services are legal, which are slightly prohibiting advertisers from gaining the full benefits of using DLT. So what are the next steps for AdsDax and the HCS? Well, we're still in ongoing discussion with our advertising partners. We aim to give them everything that they need, so we aim to be bespoke in matching their needs and coming up with a solution that fits them. So we're still exploring different setups in order to do that. We need to perform further testing of the Hedera Consensus Service on the testnet and the mainnet to ensure that we're truly production ready. So we've done quite limited testing up to now on the preview network, but we're really looking forward to getting on the test network and opening up the throttle and letting things fly. And finally, we're releasing a Go-based demo application so that we can show how we're using HCS and also how you can use it too. And the release date on that is still to be confirmed. Thanks, guys.
Thanks, Rhys. That is great. This is really exciting. I am really excited about what you guys are doing. It is fantastic. And I'm just excited to be on the journey with you. It's a privilege to be working with you on this. And I can't wait to see what happens. So that's what people are doing with HCS. What can you do? If you want to get started, here are all the different things you can do. You can go to hedera.com and it has links to all these things, but here's the links on the screen too. You can get involved with the developer portal. You can make a profile and you can get into the testnet and use that for testing, which is very useful. And lots of companies are doing that right now and individuals are doing that. You can get the HCS documentation and learn how to use HCS and how it works. If you've used Hedera at all, it's really simple. It's just one more piece of the API. You can create topics, you can send things to them. It's pretty simple. Then you can also get the SDK components. And the SDK components, of course, there's the SDK for talking to Hedera in general, but also the specific ones that we've created for HCS. And so you can get those, you can get example code, you can get all sorts of tools to help you with doing that. We want to do whatever we can to make it easy for you to use HCS, both if you are really into ledgers and you're used to a set of tools, and if you've never done anything at all before with ledgers and you want to start from scratch. Either way, we want to make it as easy as possible to use HCS, either in your existing systems to build on them or to do new things. So what's the roadmap? Well, we're going to continue building HCS, but what else? We've done a lot of things. In Q3 last year and in Q4 of last year, you can see all the different things we've done. And now, in the first half of this year, you can see that we're going to be integrating with hardware wallets. That's about to be released. We are releasing the Hedera Consensus Service. You see that on here. And then we'll be open sourcing more and more of our code. We have all sorts of code. Actually, almost everything we do will end up being open sourced. And this half of the year, we're going to end up open sourcing pretty much everything. It's very close. We will be doing open review also of the very bottom layer, the Hashgraph layer. And that's where anybody in the world can download the code, even anonymously, and you can look at the code. In addition, if you're running a mirror node, you will be able to see that we're actually running correctly in accordance with the code we released. So you can get the code, but you can also check up on us and make sure we're actually using the code we told you was our code. We can do both when you have mirror nodes. And the mirror node beta will be coming out much better than our current mirror node, faster and more powerful in a lot of ways. It gives you deeper insight. And then we'll be doing open source Hedera services and tools, just all sorts of things with HCS and with other things as well. So this is where we're headed. I really appreciate you being with us. Thank you very much for being with us. And I look forward to talking to you more in person as well. Thank you.